Hello everyone. In this video we are going to discuss that when a charged particle enters a magnetic field, the angle which it makes with the direction of magnetic field, that is the direction of the angle between the direction of the velocity vector and the magnetic field B, that angle decides the path followed by the charged particle in the magnetic field. So we are going to discuss different situations, at least 3 situations we are going to discuss, where we will see that according to the angle which the charged particle makes with the magnetic field, it traverses a certain path. So let us see that. That is motion of a charged particle in a uniform magnetic field. We are considering a uniform magnetic field. Now 3 conditions we will consider here. The general condition, that is we have a charged particle Q moving with velocity v in a magnetic field B. Okay, so it experiences a force, and we have already calculated the magnetic Lorentz force, which is given by F is equal to Q V cross B. This is the magnetic Lorentz force, or the force which is experienced by a charge Q moving with velocity v in a magnetic field B. Now, the magnitude of this force is given by QVV sine theta, where theta is the angle between the velocity vector and the magnetic field. So this we have already done. Now what we are going to see is, because of the angle which the velocity vector makes with the B, that is this value of theta, F will be defined, and accordingly the path of the charged particle will be decided. So there are three possible cases. We are going to discuss one by one in detail. When the initial velocity of the particle or the charged particle which enters the magnetic field has a direction similar to that or in the same direction of the magnetic field. So the value of theta is 0. So the force QVV sine 0 degree is 0. So that is, when the charged particle moves in the direction of magnetic field, it doesn't experience any force. It will continue moving with the same constant velocity in the same direction. There won't be any change in the velocity because the force is 0. Now, the second condition we are going to consider is when the angle is 90 degree, that is the direction in which the charged particle moves, that is the velocity of the charged particle makes an angle of 90 degree initially with the magnetic field. So if that is the case, then the value of force will be QVV sine of that particular angle which is 90 degree we are considering. So QVV sine 90, and the value of sine 90 is maximum, that is 1. So we have a maximum force. The value of maximum force is given by QVB. This QVB represents the maximum force, and we get the maximum force when the charged particle has a velocity perpendicular to that of the magnetic field. Now you need to understand that force is always perpendicular to the velocity, because QV cross B, the value of V and the force, they are perpendicular to each other. And if they are perpendicular to each other, the force does some work, but that work can be calculated to be 0. That is, the magnetic force which acts on the particle perpendicular to its velocity, it does not do any work, and we have actually discussed this topic in one of the previous video, where we have shown that if the force makes an angle of 90 degree with the velocity, then in that case the work done will be 0, that is, there will be no change in the kinetic energy. Now see here the example which we are discussing. We have already discussed that the velocity makes an angle of 90 degree with the magnetic field. Here you can see the magnetic field is given by the cross, which shows that the direction of magnetic field is inward. So the direction of force will be given by Q V cross B, cross product of V and B. You can use the right hand thumb rule or right hand screw rule, and you can see that if your curved fingers of your right hand moves from V to B, then the thumb will be towards the direction of force as shown in the figure, towards the point here, to this point. Now because of this, you will find that the charge particle now further will not move in the direction in which it is supposed to move, but it will curve, the path will be curved. Now suppose the charge particle is here, and at this point you want to represent the velocity. So velocity will be given by a tangent. This will be the direction of velocity at this point. Magnetic field is again in the downward direction, so the direction of force using the rule for finding the direction of cross product V cross B, right hand thumb rule or right hand screw rule, this will be the direction of force. So because of that, again it will bend and the process continue, and we find that it starts moving in a circular path. That is, when a charged particle enters a magnetic field at an angle of 90 degrees, then it will move in a circular path, and towards the center the force will be acting, which is the magnetic Lorentz force, and which will be given by Q V B sine 90. Sine 90, here it is 90, V and B has an angle of 90 degree, so Q V B. Now when a body moves in a circular path, here the charged particle is moving in a circular path, so it will experience the centripetal force, and the required centripetal force is provided by QVB. So I hope this is very clear to you. So if this is the case, so what we can consider now is the centripetal force, which is given by mv square by r, and here it is provided by the magnetic force, that is magnetic Lorentz force, which is given by QVB. Sine 90 is 1. So from this you can see one V will cancel out, and if one V cancels out, say here the square term will not be there, and here V will be cancelled out. So we'll be left out with mv by r is equal to qv, and from this relation we can actually find the value of r. R is the radius of the circular path, and which will be mv by qb. So I hope this is clear. Up to this it is clear. Now next we will find the period of revolution, that is, to complete the circular path the charged particle will need a particular time, which will be distance by speed. Obviously it is a circular path, so the distance will be the circumference, which is 2 pi r. So it is 2 pi r by v. The value of r we have already calculated, which is mv by qv. So the value of r which we have calculated, we put the value here, mv by qv is the value of r that we have put here. And finally the relation, you can see v and this v will cancel out, and we were left out with 2 pi m by qv. So this is the value of time period. Now number of times it completes the revolution in 1 second is known as frequency, and frequency is given by 1 by time period. So if the frequency is given by 1 by time period, so the value of frequency we can calculate, and it will be the reciprocal of this value here. So it is qb by 2 pi m. So we write here qb by 2 pi m, and we call it cyclotron frequency. That is, when the charged particle is moving in a perpendicular magnetic field in a circular path, then the frequency of the charged particle, which is given by qb by 2 pi m, is called the cyclotron frequency. We can also find cyclotron angular frequency, and angular frequency which is represented by omega is 2 pi by t. So if we use 2 pi by t here, the 2 pi will cancel out, and therefore the value of angular frequency, like which is represented by omega, which is 2 pi by t. So you will find that 2 pi cancels out, so it is qb upon m. So this is the value of angular frequency. Okay, so I hope this is very clear to you. So next is the third condition that we are going to discuss, that is when the initial velocity makes an arbitrary angle with the field direction. That is, suppose we consider an angle theta. It is neither 0 degree as we have considered in the first case, and it is neither 90 degree as we have considered in the second case. Now we are considering a charged particle which is having or making an angle of theta with the magnetic field B. Now you can see here it makes an angle theta with the magnetic field. Magnetic field is along the x-axis in this direction. So the velocity will have two components. One along the direction of magnetic field, which will be v cos theta, and perpendicular to the magnetic field, which will be v sin theta. So you can see here the parallel component that is parallel to the magnetic field is v cos theta in this direction, and perpendicular to the magnetic field is v sin theta. Now you need to understand one thing. The perpendicular component will be responsible for the charged particle to move in a circular path, whereas the parallel component will take the charged particle in the forward direction. So the path of the charged particle this time will not be circular, but it will be helical. That is, it will be moving in a circular path, but at the same time it will be moving in the forward direction. I hope this is very clear to you. So the components of the velocity, the parallel component will make it to move in a straight line in the forward direction, where the perpendicular component makes it to move in a circular path. Now, as you can see here, the pitch is the horizontal or the distance, linear distance moved by the charged particle in one complete rotation. You can see if it starts from here, again it reaches here, so this will be the pitch. Here you can it is shown here in the diagram. This represents pitch. Okay, now in this helical motion, the radius, the formula was mv by qv. Here the perpendicular component is responsible, so m into v perpendicular, which is v sin theta. So we write mv sin theta upon qb. So this is the value of the radius of the circular path. Now if we want to find the time period, it is 2 pi r by the velocity. Again the velocity is the perpendicular component of velocity, v sin theta. So 2 pi r, the value of r we have calculated, so we put the value here. So it is mv sin theta upon qv, and here it is multiplied by 2 pi by v sin theta. So v sin theta cancels out, and we again have 2 pi m by qb. Now you should understand this thing. The period of revolution doesn't change whether we are considering the angle between v and b to be 90 degree or to be any possible value of that angle which is given by theta. The time period remains same. So will be the value of frequency and angular frequency. Now the value of pitch can be given by the product of the distance, which is the product of the speed, that is v cos theta into the time period. So it is given by 2 pi mv cos theta by qv. So this is the distance moved in one particular time period, that is one complete rotation. I hope that this is very clear to you. Any doubt you can post me the doubt. Thank you.